morning. Welcome back to my stream. Let's see where we left off last time. Oh, right. So we were working last week on the editor port, and I was in the middle of trying to get the line wrapping to work properly, and it wasn't. Of course, it wasn't. So I'm doing some stuff wrong, but that's okay, because today we're gonna set that aside, at least temporarily, and try to work on getting the test cases working for, So we have 9 failures in our test cases. Yep. And we were in the middle of trying to fix them. So let's take a quick look here, and I'll just work on a couple just to knock a couple out, maybe, because it seems like all of these might be the same error, and these all look like they might be the same error, right? So we might be able to clean up 6 out of the 9 relatively straightforwardly, and maybe these 2 are the same. Who knows? So let's go to the first one. Already a variable with this name in the scope, and we can take a look at what the test case is, right? Crafting interpreters test variable. So it's just saying we have 2 arguments with the same name, so we can't be doing something like that. And then this is probably the same thing, right? Yeah, so you can't redeclare A, and then we have a collision. Yeah, so we have an A in our arguments, and then we're trying to redeclare it there. So all 3 of those should be similarly defined, or similarly failing hit status. We're clean. So whatever we were doing to try to fix it, I think we were trying to fix it last time and we just weren't getting anywhere. So I think the right thing to do is to take a look at that chapter of crafting interpreters, which is not optimization. I wonder where, maybe it would be under closures, because we had to mess around with stuff in terms of getting, well, let's see where it should be detected, right? That's the first step. Already a variable with the name in the scope, so we should be able to find that. Is that in the compiler already? There it is. Okay. Yeah, I have vague memory now of messing around in here. So we can take a look and compare what we've got here with what should be. So do we have already a variable? No, not there. Maybe it's in local variables? Yeah, okay. So we added some code here to, which doesn't exist. Oh, right, we put it in find variable. I was just looking at the loop and I said, oh, wait, there's no loop here, but there is in this find variable, there's this loop. Slowly coming back to me now. So right, we do a reverse iterate, which is what this is doing. Local depth is not -1. That means there is a depth, right? And local depth is less than current scope depth, then break. And break just goes to add local. Okay, let's see what's happening here. Right. Oh, this, okay, so in this code, we just keep carrying through the loop because the error doesn't return. It doesn't throw anything because this is C code, so it'll just keep going through the loop, and then eventually it'll call add local anyway. But because we errored, we'll do this the synchronization and then carry on. But here, what we're doing is we're saying if there's a depth, right, and that depth is less than the current scope depth, then do the add local. And what's happening here is it's saying if depth of 0, why am I checking 0? If it isn't, then add local. Okay, and here, up here, if it's none, we return uninitialized. If we return uninitialized from here, we're going to return add local. We're going to call add local. Oh, okay. So maybe this is the issue here, that we don't... So what's the right answer? And maybe we can start off, I'll comment this out just so we have it as reference, and we can just match. That way we can do different things. Match on this. Because we can either be not found, uninitialized, or have a depth of some kind. And that's this depth here. I think. Right? And that's the only reason I would have put that in there, is that if this was the actual depth. Do we get a depth? V depth is none. We don't get the actual depth of the local here, right? Is that the bug? Is that we should be putting the depth in here? Let's take a look at what depth is. Because V is a local, right? Oops. Let's do that. Yeah, it's a local. Struct local contains an option use size for depth. So I've now lost find variable. There we go. So should we be doing it this way instead? Match V depth, none, return find result, and if it's some D, that's probably going to break a bunch of other things, right? That's depending on this find depth. But let's see. Should I just be returning the depth of D? Right? And then this can check that depth. If it's none, if it is this and then the identifier is equal, that's where we check. Oh, yeah, so that's the uninitialized part, right? So if it's uninitialized, that means we found this. If it's not found, then we just add local. We ignore it and add local. If it is found and it's initialized, then we can just add it. I'm getting lost now, aren't I? Okay, so if this is find result uninitialized, that means we found it, so we have to report this error. Right? Probably have to do it this way, right? Because these are all going to have different things. And then find result depth of D. We found a depth, then we're going to check to see if the local depth is less than the current scope depth, which I forget how to grab. Let's find out. If D is less than, I don't know, self, current, I don't know what it is, scope, depth, then we'll just add local and break. There's nothing to break out of here. The only other option it can be is find results, not found, in which case we also want to add local. Right? If we found it and the depth is greater than or equal to the current scope depth, and we still should need to check this. So this isn't quite the right answer. Oh. Okay, I think that means just put an else here, right? Right? That's kind of annoying to have this multiple code twice. We have the 2 errors. You have the error case twice, and we have the add local case twice. I don't know if this is going to break everything or fix everything. Let's see if it builds. Nope. Oh, as you wait. What's the other error? Oh yeah, I haven't figured out how to get current scope depth. Okay, let's figure that out. Scope depth is a ref cell, which means we have to borrow. But how do we get current? Current is going to be what? That's the current parser. How about, oh, local count we wouldn't have because that would just be the length of whatever array we have. So it's locals, right? Compile result. Ah, right, it's in the compile result. And how do we get access to the compile result? It's in a ref cell also. So result, compile, borrow. Scope depth borrow. That's a U8. Oh, right. And that's going to be a ref cell. That's going to return a ref. That's going to be ref cell view size. And it doesn't say. So we probably have to put a star in front here, right? Nope. Expected U8 found U size. Oh, right, because D is a not disturbed. Oh. Like that? Almost there. Too many variables. Which should never happen, right? Because too many variables should panic before we even get there. Okay. Find variable. Yeah. Too many variables should never happen here. So I can just panic for that one. How's that? Okay, we have 2 warnings though. Oh, we're not using the enumeration. Okay, this is probably not good because like I said, I've just changed the way the depth gets calculated. Let's build this. No default features. And run this over here and see what blows up. Yeah. So that was all wrong because it's failing now to find correct variables. Yeah. Something's highly broken. So let's undo that. Git checkout dot. And try again. Okay, so it's in find variable. Here, declare variable. All right, so instead of doing what we just did, let's take a look at making it such that we can just see, grab the depth this way, and then check the depth here using this code. Right, this is in declare variable, so this is where we should be doing this anyway, right? D is less than, oh, now I forgot what it was. Was it self result, borrow, current, scope, depth, borrow, as U8. I'll put the U8 there instead of the U size on the D. Then we want to add local, else error. All right. That's a smaller change anyway. Let's see what this does. I should probably have this building in the background, right? Oops, I don't want to print. Yeah, let me kill this and go over to logs bytecode and have this cargo watch. Build, release, no default. Oh, do I have to put this in quotes? Yeah. Oops. I don't know what I was doing there. Okay. Okay. And now we'll run this again. One more try. Oh! Yeah, look at that. 6 tests failed. As opposed to 1,000,000. But as opposed to... we had 9 tests failing before. And now I think these first 3, shadow and local, and... Nope. Yeah, already a variable with the name of the scope. So these 2, anyway. And there's also this scope one here. So I got to figure out which one's passed now. Yeah, so all those scope ones are working now. Okay, so that's one bug. And that was a lot simpler than whatever I was doing the first time around. Just following this code right here. Okay, so let's commit these changes. Git commit. Oh, add source. Oh, let's check in with Clippy. So I don't know if I set up. Did I set up the thing with the git hooks? Pre-commit. Yeah, I did. Yeah. Okay. So git add source, git status, git commit -m, fix scoping bug with redeclared variables. Sure. Good. Okay. And then I have the cargo watch over here just building it every time we save. That's fine. All right, so now we have this bug, which I think if we figure out whatever this is, we'll fix all 3 of those. We have a local recursion bug where we're panicking here on line 81. We have a scanner bug where we're panicking on line 243. Okay, so let's take a look. Decimal point at EOF seems like an easy one, right? Because all we need to do is check to make sure we're not none. Let's find out. Let's find out how bad that is. Scanner. Line 243. Yeah, okay. So this should be checking here. If is at end, returns none, right? Otherwise, we go up by 1. So this peak next is insufficient. Is at end looks like this. If current is equal to the len. If current is less than the len, then we can't peek ahead with this peek next sheet. So we can't do this. Well, we have to say if current, what was that again? Self current, yeah. Self current plus 1 is greater than or equal to self source len. Then we're going to return none. I think this will fix this one. Right? At a minimum, it's going to say it'll return a none, and then there may be something that has to handle the none case. Okay, so I built. Let's see if that fixes this decimal point at EOF. No. But yeah, so it was what I suspected, right? Okay, so now we have to bubble up to line 205. Line 205 is here. Well, we're assuming that peak next is going to be working. So I think the right thing to do is here is say if self peak is equal to this, then if let sum ch is equal self peak next. If ch is digit, self advance, and then these. I'm just looking down here to copy, and then here. That's the digit, and that's the let, and that's the that. Is that it? Yeah, I mean, that looks right. Okay, let's see if that builds. It does not. Oh, is digit 10. Right, okay. And then this builds. And then we run the test. Ah, okay, so that fixes that. Okay, git add. Yeah, and all I did was handle the UF case properly. Git add source, git commit -m, handle decimal point at UF. Very good. Okay, so there's 2 bugs fixed, and it's got us down to 5 failures instead of 9. And like I said, maybe this one is just the same. This all looks like the same bug, right? What does this look like? Oh. Yeah, I think I remember trying to look at this before and trying to figure out where this was going to be. So we were expecting to see invalid assignment target, and instead we saw expect semicolon after expression. So there's something we're detecting that we're not seeing that this is an assignment target. Maybe it's time to switch over to my editor now. Not that I've messed around in here enough. All right. Yeah, so it's saying if we can assign it and it's an assignment token, but we're in this precedence rule thing here, which I'm struggling to remember how this all works, then we have an invalid assignment target. But instead what we're seeing is we're parsing it as an expression, and we're expecting just a semicolon to be there. So let's see if we can find that after expression. Oh, look, I even put a comment in here saying this is what we need to be handling. This is the issue, right? This is okay. But this should not be okay. So we're calling expression for expression statement and then expecting a semicolon after that. So let's take a look at what the code looks like here. Compiling expressions, maybe? Expression statement. Nope. Let's try the next one. Nope. Hash tables, global variables. Here's expression statement. Yeah. So expression calls expression and then says expecting a semicolon. And expression is just parse precedence. So yeah, maybe there's a bug in this code here. Are we generating both errors? Let's find out what we actually generate. If I run this and run the grouping on it, what error do we get? Okay, so we only see that one error. We don't see invalid assignment target and this error. So we must not be seeing this can assign business. can assign is this precedence is less than precedent. Okay, so let's see if we can find parse precedence. I'm just looking for the code itself. It looks like this thing has plenty of examples of parse precedence. It's just looks like we already wrote it somewhere. Not here. Parse precedence is already defined by the time we get there. Okay. Oh, right. So we changed it up quite a bit, right? Because parse precedence. Oh, parser. Oh, right. Yeah, we had the whole precedence table for every token type. Here it is. So there's advance. We get the rule. If it's null, we expect an expression. That's this thing here. Otherwise, we call prefix rule. And then we expand on it over the course of the various chapters to make all this happen. And it looks like maybe we messed something up here. This is this here. So here's prefix rule. While precedence is less than or equal to precedence of the current type, we advance. If we have an infix rule, we call it. This says there's always going to be an infix parse function. Oh yeah, because some of them are just none. No, we can have nulls there. We don't want to just call it indiscriminately, right? Here's prefix rule is none. This is assuming that there's going to be an infix rule. I guess there always will be, based on the way it works. We'll plug additional parsing functions into the table when we add new kinds of expression, but parse precedence is complete, except for the whole can assign thing, right? Because maybe that's where we mess up. Because this looks all correct. We call the prefix rule, which we grabbed out of the table. If it's null, we hit expect expression. This line here, can assign, is new. So we're not going to worry about that just yet. Right, because we're going to pass that in at some point. And then while precedence is less than or equal to the precedence of the rule of the current token, we advance. And we grab the infix rule and run it. That looks correct. All right, so let's look for any other changes that happened to it. Parsing infix. And in binary, parse precedence of the next precedence. I think I have that, right? Yeah, precedence next. I shouldn't call it next, I should have called it SUCC, right? For successor? Okay. And then there's all of these, okay. And then we keep going. This is where we explain how it all works. There's the precedence. Here's where we handle the prefix rule. That's it. Okay, so let's take a look to see on the next chapter. That's the only instance of parse precedence, so we don't have to worry about that. There aren't any in here. There aren't any in here. Here we go. Oh no, this is just... Okay. So this is the... Yeah, so this is where we handle the assignment thing. Okay, so here we go. If can assign is equal to, precedence is less than or equal to the assignment precedence. and then we pass in can assign to the prefix rule. That all works. For all of the prefix rules, we had to add a parameter to them so we could pass in this can assign thing. And then here, oh, this is in named variable. And this is in parse precedence. So let's take a look at named variable. Do we check for that? If can assign and is assignment, token equal in here is token type assign over here. Okay. And then if can assign and match token equal, then we say invalid assignment target. So that's where this comes from. And it's right after the infix rule. Oh. Oh. Maybe that's not supposed to be in the inside the while. Maybe that's supposed to be outside the while, because I see infix rule here and then close brace, and maybe that's why I did this, but there is no extra layer of indirection in let's move that around. Maybe that's the bug. Let's find out. Okay. I was checking in the wrong spot. It builds. Okay. Now let's run this. Wow. Okay, so that fixed these 3 errors. That's good. All right, so we're down to 2 errors left. Git add source, git commit -m, detect proper detection of invalid L values in assignment. Boom, 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 boom. Okay, we're down to 2 errors, and this looks like an EOL one, and then this one I don't know what the problem is yet. We'll figure it out, and it's probably related to that find variable thing. I was going to switch over to the editor, but now I think we're close, at least on this one, and then I'll have to think about this one, and maybe tomorrow morning we can work on that, and I'll get back to the editor now because it's still fresh in my head. So let's take a look at line 81 where it's panicking. Obviously, it must be that offset is too large, right? Len is 1, but index is 1. So we're calling capture upvalue on an invalid offset. Oh, this might be tougher than I think, because if local, so the captured value is, if it's local, we give the slots plus the index and then captures it. You'd think that none of this would work if this calculation is wrong, right? None of the other things that use closures would work. And yet, so what's special about this is that, okay, it says local recursion. So it's in a scope. And trying to capture n, and n is not on the slots of the current frame. Self-stack offset. So len is 1. That means there's only 1 entry on the stack, and we're already trying to pull an entry off the stack. Okay, so I guess we can look at that. Would that be under closures? Op closure? Okay. So this is the simple version of it. Oh no, that's the, sorry, simple version. That's the disassembly of it. Okay, so here, this says function as function read constant. And that's what this is doing. So this is the function. Here's the read constant call. And here's where we extract the function from the constant. We're going to create a new closure. We haven't done the up values yet. All right, so there's some code in here we haven't done or haven't looked at. By the time we get here, it's very simple, and then it gets more complicated as we go through the chapter, right? So we create a new closure. We push the closure. So all of this comes in this up value stuff. So that's the call. I'm just looking for, yeah, so this is, okay. Yeah, this is not it yet. Interpret, we're going to replace one line. Oh, right, because we had to create the closure for the first thing. Okay, I mean the scope for the first thing. Okay. I'm just scanning forward to the code to see what's going on. There's named variable, resolve local. I'm looking for VM run because those are the additional changes. Add up values. I don't even want to think about that anymore. Debug. Oh, here's up value objects, right? So we have, this is something that's new for this. We have a function called new up value, which creates the up values in object.c. We don't have object, we do have value, right? And value contains up values. Oh, it doesn't. So what do up values get stored as? Up values, oh, there's an up value count. Where do the up values get stored? If I look at here, up values. Oh, that's just, okay, yeah, it's just a number. Okay, and then we go from 0 to here, we grab the up values from the chunk. I see. All right, so we have up values, there's up value count, but it looks like we need up values somewhere, right? And that, oh, there's that enclosure. Here we go. This is where the up values are. Okay, found them. And what is an up value? An up value is just a location. It's a type of value. And you can overwrite it. And I call it location. Okay, all right. Trying to remember all of this. Yeah, okay, so here's in VM run, right? This is the loop that we're looking at here. So from 0 to up value count, right, which we get from the current function, I guess. This says closure. Oh, I see what's going on here. We're pushing here, the closure, and here I'm pushing it down here. So that's probably what's going on, is we're trying to extract. Does that make sense? We're trying to extract the data from the closure that's already on the stack, but it's not on the stack yet. But if I do this, is this going to fail because I've just created the closure and now I can't modify it? Right, this is going to fail because the closure will have been moved onto into this stack thing here, and we won't be able to build this, right? Yeah, move occurs. Okay, so we have to get around it by doing rc new this, rc clone of this, And then we can still modify it using the original RC, and then we drop this one so we're back down to a single reference count. Wild stab in the dark. Okay. Well, it didn't complain. Looks like it built. Will it pass the test here, though? On local recursion. Look at that. Okay. So that was that bug. Git add source. Git commit. Allow variables to reference local scope on recursion. There we go. So now we're left this one problem. So now again, I'm tempted, I should just fix this instead of work on the editor again. Although I don't know what the bug is here, right? Expected output 4 on line 17 and got 1. So okay, we're expecting 4 and then we're expecting 1. We're expecting 4 and then 2 and then 4 and then 3. So we're printing I and then J. So what's happening here is we have a global variable I that we're capturing here, but we're capturing a reference to it. So it should be, so we're obviously getting 1 1 2 2 3 3, right? Based on this error output here, which means that this I is being copied instead of a reference to it being given to us. I wouldn't even know where to start looking for that kind of a bug. What does the code look like? If I say cargo run, oops, I code the source, crafting interpreters with this test. We can take a look at the code that gets generated. Oops, I didn't think it was going to be that long. Okay, it looks a lot smaller than it actually is. So here's function f, get up value 0, print get up value 1, print. So this is the main script, right? Where we have a for loop. Well, we define these three variables, right? We then push the constant 1, and then we have local 1. And then we check it against 4, jump it false to 88. Which pops it, closes the up value, right? Because we defined the function now. So we have to close up value. Doesn't say what to do, it just, I guess we close all up values, right? Maybe the bug is in close up value. Because that's the thing that would be determining what these, where these get referred to. And then here's the three function calls. F1 call, F2 call, and F3 call. Right. And if I look at these, I see, yeah, 1 1 2 2 and 3 3 instead of 4 1 4 2 4 3. Here's calling 0, which is F1, saying get up value 0, which is finding a 1 and printing that. All right, so maybe just as a first look to see how does close up value work and how close is it to the code that we actually have here, right? Because this is closed up values. I'm first take a look at git log and see how far back this is. So we have to go back to 25.4. Closed up values, and I said, do we really need this? Well, I guess we do if we're going to pass this particular test. Remove clone clause from popped oh, that's interesting. Maybe that's the bug. Diff. Maybe this should be an RC. Ooh, bound method. I don't remember that. Not diff, show. Okay, that makes more sense. Oh yeah, this was just something that Clippy was telling us we should do. There's no reason to clone it. Okay, so that's something different. 25.4. So let's take a look at this. Here's close up value, right? Close up value. So what do we got? Capture. And then we have this business here. And then we check to see if it's captured. And then we have some code here inside the compiler. It would be nice if it... So the diff I'm running it does all this fancy kind of stuff here, but it would be nice to say, it's great just telling me it's in the compiler, but it should also tell me what function it's in. And it's not doing that. That's unfortunate. Okay, so that's it for that. Close up value just is pop. Huh. Okay. Oh, hello there. D3PSI? Is that an I or an L? I can't tell. Despel? Good to see you. Thanks for stopping by. Nope. Okay, so here's where we do captured business. Is that what we did here? Yes, so we added this is captured as false. That's that. Likewise, the special slot 0 local that the compiler implicitly declares is not captured. That's, well, actually, that's what that is. This is the slot 0 local, right? And then when we capture, this says captured is true on capture. When resolving an identifier, if we end up creating an up value for a local variable, we mark it as captured. So this is in resolve up value. Let's take a look at that one. Inside the compiler. Let's take a look. Is captured. Depsy. No, it's Depsy. Okay. Sorry, Depsy. How's the VM going? We're almost done. We're actually almost done. We have one error left out of, we started off with 9 test case failures. Oh, this was 37 failed because I had a bad fix. Now we're down to 1 failure, and that's what we're trying to track down. Resolve up value, right? This is new. That's not what we're looking for. Capture is captured. Where's resolve up value? Here it is. Oh, that's interesting. Oh, this is just because before we call add up value. So where do we call add up value? Oh, here in resolve up value. Duh. Okay. So if local is not 1, that's this. Is not, sorry, not -1, which means in our code we set local to none instead of using this -1 thing. So that means we come in here, we call capture, which I'm assuming is setting is capture to true. Right, yeah, we were just looking at that, right? Yeah, it sets is capture to true. Well, it sets compiler enclosing locals local is captured to true. Which is the same depth business here. Oh, Depsy says, I also recently built a VM, started as a joke, and made it a reality. Oh, for the white space programming language? Yeah. Yeah, that's with spaces and tabs as being, and then you make it Turing complete, right? By defining what the spaces and tabs and new lines do. I've seen that before. It's a funny language. It's a fun language. Okay. And then self local's borrow mute index is new local. So that's what this add up value is doing here. Right, it's just inserting a new, oh, it is putting true, right? Which should be fine. Self-enclosing, borrow, as ref, unwrap, capture. So here's it captured. And we're cloning it. Maybe this is the problem? Because it's a local. And we're just cloning the local, and that's how we're ending up with the 1 instead of let's print one. The new local. Depsy says they're writing it in Rust because Rust is the one and only. Well, yeah, I'm definitely enjoying the hell out of Rust. It's a lot of fun to write code in. Okay, did that build? That built. So let me try running this. Locks bytecode, target, release, locks bytecode. So it's capturing I and capturing J, but it should be capturing I and not cloning it. It should be capturing the reference to the I. What is self-locals? It's a ref cell of a vec of locals. And it works in every other case, it's just that this particular case is failing. And I think it's because oh, I see what we're doing. Locals borrow index clone. We set it to captured, and then we just copy it back in, overwriting the previous one. Because that's the only way we could do it right. Because otherwise we'd need a mutable reference to self here, and then we'd have issues with borrowing mutably and immutably. But so this should work because we're rewriting the value. The value is still going to be the same. What does local look like? Maybe there's some stuff in here we're not handling right now. There's a token, the depth, and the captured thing. This capture is false, but then we set it to true, and then we insert it back in. Oh, this says 5 and 6. 1, 2, 3, 4, 5, and 6. Yeah, so here's where I first appears, and here's where J first appears. So that makes sense. That's where they would be captured from. I honestly don't know what the issue is. Don't know what the issue is. I don't know why this isn't doing this. All right, well, let's keep looking. Here's end scope. We can take a look at end scope. Make sure that gets done, right? There's close up value. We're definitely omitting that. We saw that in the output. Tuesday evening says, are you using Vim without any extension? Dope. I wish I could be dope. I am not dope. Let me tell you the extension I'm using. This. There's a few of them. Let me put this in chat. All I'm doing is there aren't that many extensions, but there are enough. So it's basically these guys. So I have the fuzzy finder, right? So I can search for stuff. I actually don't know what utilisnips does. But it does allow me to hit Control D, which saves and then runs a cargo check and populates the quick fix list. So if I did that, right? And now I've got this quick fix list saying, oh, look at that, I got 6 errors I can tab my way through. And then fix it, and then compile it, and I see 0 errors and 0 warnings. So that one's really handy. And then also Shift K is kind of handy. Like I could check the type of anything by hitting Shift K, and it'll just pop that up. Token type. Looks bytecode token, tells me where it comes from. I also have, you know, like GD for jump, go to definition, stuff like that. So it's kind of handy. And I'm sure there's a bunch of other things. I'm not sure what Vim wiki shortcuts there are, but there we go. And then of course LSP. Okay. What do I want to do then? I guess we can just, yeah. Let's keep just scanning through. Maybe there's something else that'll jump out at us. This is the decompiler. Here's up values. Don't care about that. That's all that. This would all be failing if. All right. So then, is it in the VM that we have capture up value? Okay. Okay. I already see a problem, right? Because this is just clone. And it looks like there's supposed to be some other stuff here. Did I just miss this when I was writing the code? Object value up values null. Up values VM open up values. So we must have an open up values thing somewhere, right? I don't see it. Open? There's no open. Is there open with a capital O? No. Huh. How did I miss that? Did I just like skip this whole section? Tracking open up values. Sika says you can remove the VM wiki if you don't use VM wiki in Vim, a wiki plugin. Utilisnips is a code snippet provider. Okay. I'll have to look up how to do that. Oh, and then Nova I don't know how you would pronounce that otherwise. Thank you for the follow. Much appreciated. Did I just skip this whole section? Because I don't see this. So this is just creating a linked list, right? Which we're not going to do in Rust. We're not going to make linked lists. We would just use a vector. But this looks like we're going to actually have in our VM open up values. And an open up values would just be up values. How would I have missed this? RC. It would be a vec, right? Ooh. I'm trying to think of where the ref cell should go, right? Because right now I think we're just going to add it to a linked list, right? We're going to start here. All up value is not null, and up value location is greater than local. Previous up value is up value, up value, up value next. So we're just walking the linked list to see where to insert it in the open up values list. Okay, now I'm distracted again. So VM, what's the key code for Vim wiki? Personal wiki. Oh, I see. I don't know what keystroke is bound to it. So that's something I should play with. And then util the snips. Alta snips. I was saying it wrong this whole time. Alta snips. Is there a expand trigger tab? I wonder if toggle already had some snips defined. Let's find out. Nope, it would be, where would it be? It would probably be in the Rust thing, right? I don't see any snips here. I don't know where else to look. Syntax, Rust. Send keyword to do bug. Okay. Maybe it's in a thing called utilisnips. Ultisnips. I don't see a Rust one though. Oh, here it is. Oh, look at this. Snippet struct. Create a struct. Let's see if that works. I'm just going to play with this now because I'm distracted. Struct. Tab. Nope. I wonder what the key trigger is for Ultisnips. Oh, thanks, Sika. Yeah, I think we must have found it just about the same time there. I mean, it's right there. How did I miss it? Okay, so would it be here? I'm just looking for what the trigger is for it. Snips, snips, snip. There it is. Oh, leader T. That's not going to work because I have leader T mapped to test. All right. Did I make any changes, or is it just all that? Yeah, let's get rid of this. Yeah, okay. So I have to change it to something else. nvim source. No. .config. nvim nolo. There we are. So it's snip. Snip expand trigger. Leader T. Maybe P for expand? Let's find out. So if I say struct and then leader P, look at that. Ha! Okay. I learned something new. Oh, look at, and now I can also change this thing here? No. Oh, it was working though. Let's undo that. So struct leader P, and now I can type in name, and it puts it down here as well. That's really cool. All right, and now I have to learn what all of the snips are. Struct test mod, that's cool. Write a test. Impit, implement iterator 4. Okay. Default, this is the default macro. Main function. New. Bench base. I add bencher. Address boilerplate. That's very specific, isn't it? That's useful for like network coding, but okay. And then PL is ePrintln. Okay. I'll have to see if I can remember to use these, because this is kind of neat. Undo. There we go. With that having been completed, let's take a look here, because it looks like what we need to do is walk this list, right? And find the spot, quote unquote, to insert it into the list, and then, oh no, it's just walking the list. It's not inserting anything. It's just finding it. And if the location is equal to the local, this is a pointer comparison, then we're going to return the up value that we just found on this list. Tika says you can also create your own Rust snippets. Yeah, well, I figured as much. Yeah, based on the fact that we could just edit this file and we'll be happy. Oh, CMT, comment. CMT. Look at. Okay, sorry. There we go. Here we go. So this is trying to find an up value if it already exists, I think, yeah, this might be the bug, right? If we're missing this code, the I already exists, maybe as an up value, and we're just not capturing it properly. So we have to actually return this. So let's take a look at capture up value, which is not here, it's in the VM. Right? And we're returning, this is returning a value, but I think value contains up values, right? Wasn't that the case? I hate it when my keys get off the home row. Oh, right, yeah, there are no quote unquote up values here. So an object up value is just an up value. It's just a regular value, right? Where's up value? Object up value. Yeah, but let's search from the top here. Where's the first instance of it? Is up here. Before we process those operands, we need runtime representation for up values. So we do have up values here, and it contains location. Location is just a ref cell, sorry, it's RC to a value. Right? Which makes sense, right? Because we're just making a reference to it, and then we want to compare as we walk this thing. As we walk that list, we want to compare the pointers. Here's new up value. Takes the address of the slot where the closed over variable lives. Here's the implementation. And all that is this. We're cloning the value. We're cloning the reference counted ref cell. We don't have to worry about freeing it. Here it says finally to print, but I don't think we print it ever. So we don't even have a toString in here or a display thing. And then in closure, we have a vector of up values. Okay, so let's take a look at closure. All right, we looked at this before. Up values is a vector of reference counts to up values. So when we create a new closure, we create that. So that's this. Oh, Sika says for future reference, you can find some useful Rust snippets here. All right, let's take a quick look. I don't mind getting distracted here. Oh, okay, yeah, these are just basic. That makes sense. And then this one here, somebody else wrote some more. Priority -50. Oh, okay. Yeah. So this would speed things up a little bit. And then I guess over here. Yeah, so this is a bunch of conflicting ones too, right? So I have this one and I have this one and this guy has this other one. Okay, but thank you for that. I will take a look at those. And there's my crab emoji. All right, so here we go. So when we create a new closure, we create a... Oh, okay. So what we're doing here, when I create a new closure, I just create an empty vector. This creates... So this should be like with capacity, maybe? Or just have them all be... This says null. If these are nullable, then this should be options. Or not. And we store the array in a new closure as well as copy a count over from the object function. This is a new closure. So we know what the count is. And I'm not saving that here. And there's freeing it. Okay. Object closure does not own the object up value objects themselves, but it does own the array containing the pointers to those up values. Oh, right. So here's where we push everything on. Right? So all we're doing is assigning all of these guys, and we have the up value count, and it should be equal to these here. And this is just initializing the memory, because if you're dealing with uninitialized memory, right, that's undefined behavior in some instances, and so you want to be careful about that. Okay, so we're going to eventually push all the full up value count anyway, so that's the same up value count as this. Okay, so that we don't have to worry about the nulls, and we don't have to worry about the options then. And all we have to do is figure out how to make sure we're capturing the correct up value. Because it's either, if it's local, we want to clone the RC here to the up value. And if it's not local, then we want to clone this guy. So let's take a look again in VM, up values, there. Yeah, and then we say closure push up value. So that's what this is doing, and then it's saying captured. So captured should be a ref cell. Yes, RC ref cell to a value, which makes sense because we're trying to capture a reference to it. And then get up value. I'm pretty sure that's working. All right, there's read byte, and then we just self-stack push clone of the ref cell. Here's the set. Read byte, we peak of 0, and we set it to the value. That makes sense. Now we have closed up values. Okay, so I think our issue was the fact that we're trying to do this tracking the open up values thing here, and we're not doing that yet. Okay, so that must be the bug. That we're missing all of this code here. Because when we capture the up value, we want to be able to return with any open up values that are currently on this open up values list. So the question is, where does that get set? So let's look for open up values. It starts off as null, so it's going to be empty. And then here in capture up value, yeah, so I must have totally just missed this section completely, right? What section is this? Or did I just look at it and say, you know, we don't have to do any of this? 25.4.3. 25.4. Closed up values. Yeah, I don't have it in here. I don't know, what was I thinking when I said this? Past me was such an idiot. Okay. Anyway, it's just only one test fails. Okay, it's not that big a deal. Okay. Reset stack. Does that exist? There is a reset stack. Okay. Self-stack clear. So I think we do need to create this here, right? Open up values. And it's going to be vec rc ref cell. And it's going to be up value. Right? Which I don't have here. Uh-oh. Trying to think of how this is going to work. Because the up value contains, contains the location. Okay, so let's import that. Right? And then when we initialize the VM, we have to initialize that. Open up values, back new. Is that all we need to do just to get this to compile? We get warnings that we're not using it, but that's fine. And it's going to be empty. It's going to start off empty. So in capture upvalue, we're going to say, we're going to look for it, right? For each one, we're going to check to see if its location is greater than local. Okay, so that's going to fail miserably, right? Because this is pointer comparison. And we don't want to do that in in Rust. We don't want to say, is this pointer somewhere in memory after the thing we're looking for? Because that's what this is doing, right? It's got this array here, and it's just saying, okay, well, this location is here, this location is here. If this upvalue's location is past the local, then keep going. We keep working our way through all the up values, right? This is the start, the next is back here, next back, until you get before the local. And once you're before the local and you found it, it's equal to the local, then that's the one we return. Otherwise, you create a new one. So location, let's see, actually, let's take a look at, location is a value. And I don't think I want that anymore, right? I just want it to be the index into this. This is the stack, right? That's what we're checking to see where is it in the stack. Okay, this is going to be tough. This is going to be something I need to sit down and think about how to implement, because this is not the right approach. What I'm doing, because doing this pointer math stuff is not. Okay, let's read this and then see where we can get from there. The list starts out as empty. Starting the first up value pointed to by the VM, each open up value points to the next open up value that references a local variable farther down in the stack, right? So we might be having to store this, not the location as a RC, but the location as an index into the stack. But then we need to be able to compare it with local variable. We need to know its location in the stack as well, and we don't know that. Maybe we do, when we call here, we do. We know it's offset. Offset is usize? Yeah. So we'd have to store here the usize in the up value, not a value. All right. When we close over a local variable before creating a new up value, we look for an existing one on the list. We start at the head of the list, which is the up value closest to the top of the stack. We walk through the list using a little pointer comparison. Yeah. Just a little tiny pointer comparison to iterate past every up value pointing to slots above the one we're looking for. It's a singly linked list. It's not like we have any other choice than to start at the head and go forward from there. While we do that, we keep track of the preceding up value on the list. We need to update that node's next pointer if we end up inserting a node after it. Right. Right. I mean, this is standard linked list stuff. It's just walking backwards instead of forwards, and we're using just a little tiny pointer comparison. Okay, there are 3 reasons we can exit the loop. The local slot we stopped at is the slot we're looking for. We found an existing up value capturing the variable, so we reuse that up value. And I think that's what's happening here, is we're not reusing the I. We ran out of up values to search. When up value is null, it means every open up value in the list points to locals above the slot we're looking for, or more likely the up value list is empty. Either way, we didn't find an up value for our slot. So we just came off the end here, I guess. Next is null. That's what that little tiny slash in there means. Or we found an up value whose local slot is below the one we're looking for. Since the list is sorted, that means we've gone past the slot we're closing over, and thus there must not be an existing up value for it. In the first case, we're done and we've returned. Otherwise, we create a new up value for our local slot and insert it into the list at the right location. The current incarnation of this function already creates the up value, so we only need to add code to insert the up value into the list. We exited the list traversal by either going past the end of the list or by stopping on the first up value whose stack slot is below the one we're looking for. In either case, that means we need to insert the new up value before the object pointed at by up value, which may be null if we hit the end of the list, right? You insert a node in the linked list, you set the next point to the previous node to point to your new one, and then you have to point the new one at the current one. We also need to handle a special case when we're inserting a new up value at the head of the list. There's a shorter implementation that handles updating either the head or previous. Hasn't reached some Zen master level of pointer expertise. Yeah. With this updated function, the VM now ensures that there's only ever a single object up value for any given local slot. If two closures capture the same variable, they will get the same up value. Yeah. So I think that's what's happening here. Is we're creating three closures, right? 1, 2, and 3. And we should be capturing the same I each time, but different J's each time. So that's the bug. That we never, I just either ignored this, or when I read it over, I said, you know what? Why are we doing this? Based on the log comment. Yeah. So I don't have enough time to implement that today. So instead, what I'm going to do is I'm going to undo these changes, right, to get back to parity with where we were. This should be clean. I'm going to push this up, and we're going to call it a stream. And then tomorrow, where's my? All right, I'll just create a new one. Expect code. Here. Okay, so these are the fixes we did too. We fixed all but one bug, and this last one is a doozy. Where is it? Over here. Okay, so that's that. I'm going to end the stream here, and then the next stream, which hopefully will be tomorrow, but maybe Thursday instead. I don't know what my schedule looks like yet for tomorrow. We can fix this final last bug and then get back to the editor, because I left the editor kind of halfway in the middle of the fix. So there we go. All right, thanks everyone for hanging out with me. I had a lot of fun. I hope you did too, and I will see you next time. Take care.